We think of the ground beneath our feet as the very definition of permanence. The land is what everything else rests upon, the fixed and unchanging stage on which our lives unfold, so solid and so still that we use it as a metaphor for stability itself. And yet across the American Midwest, and indeed across much of the middle of the continent, the ground is not standing still at all. It is sinking. Slowly, quietly, imperceptibly, far too gradually for any person to feel or see, the land across a broad swath of the American heartland is settling lower year after year, and it has been doing so for thousands of years. For a long time, this quiet subsidence was a puzzle, a movement of the earth that scientists could measure but struggled to fully account for. But now, with the remarkable precision of modern instruments and a far deeper understanding of the planet's long history, scientists have finally pieced together a compelling and elegant explanation for why the ground under the Midwest is sinking, and the answer reaches all the way back to an age when much of the continent lay buried beneath miles of solid ice. This is the story of that quiet sinking and of the surprising and profound deep-time cause that scientists have at last found behind it. To understand why the Midwest is sinking, you first have to travel back in time to the last great ice age, when the climate of the Earth was far colder than it is today, and enormous sheets of ice covered the northern parts of the continent. These were not mere glaciers of the kind that cling to mountain valleys today, but vast continental ice sheets, sheets of ice miles thick that spread down from the north and blanketed what is now Canada and the northern United States. The weight of all that ice was almost incomprehensible, a burden of trillions upon trillions of tons pressing down on the crust of the Earth. And the crust, for all its apparent rigidity, is not perfectly stiff. It floats upon the hot, slowly flowing rock of the Earth's mantle beneath it, and under a great enough load, it bends. The immense weight of the ice sheets pushed the land beneath them down, depressing the crust into the mantle like a heavy person sinking into a soft mattress. But here is the crucial part, the piece of the puzzle that explains the Midwest. When you press down on one part of a flexible surface, the surrounding areas bulge upward in response. The way pressing your hand into a mattress causes the material around your hand to rise. The same thing happened with the ice sheets, as the enormous weight of the ice pushed down the land directly beneath it. The land around the edges of the ice, in a broad ring beyond the ice margin, was pushed upward, rising into what scientists call a forebulge. The regions just beyond the reach of the ice, including much of what is now the Midwest, were lifted up as the crust flexed around the depression made by the ice. For thousands of years, as long as the ice sheets sat upon the land, this forebulge stood raised, a swell in the crust created by the displacement of the deep rock squeezed out from beneath the ice. Then the ice age ended. The climate warmed, and over thousands of years the great ice sheets melted away, releasing the land beneath them from their crushing weight. And when the weight was lifted, the crust began, slowly, to spring back. The land that had been pressed down beneath the ice began to rise again, rebounding upward now that the burden was gone. A process that continues to this day in the regions that were once buried, such as parts of Canada and the far northern United States, where the land is still rising measurably as the crust recovers from the vanished ice. This rebounding of the once buried land is one half of the story, but the other half, the half that explains the sinking Midwest, is what happens to that forebulge, the ring of raised land around the edges, when the ice that created it disappears. Because the forebulge was only held up by the displacement of rock squeezed out from under the ice. It was a temporary swell, propped up by the presence of the ice sheet pressing down nearby. When the ice melted and the depressed land began to rebound, the rock that had been squeezed outward flowed back toward the areas that were rising, and the forebulge, no longer supported, began to collapse. The raised ring of land started to sink back down, settling toward where it had been before the ice ever arrived. And this is precisely what is happening across the Midwest today. The region sits on what was once the forebulge around the great ice sheets, and now, in the long aftermath of the ice age, that forebulge is collapsing, the land subsiding slowly as the crust continues its long, patient adjustment to a world without the ice. This is the deep cause that scientists have identified. The reason the ground under the Midwest is sinking, it is the slow motion collapse of a bulge raised by ice that vanished thousands of years ago. Scientists give this whole grand process a name. They call it glacial isostatic adjustment, which is a technical way of describing the way the Earth's crust continues to rebalance itself in response to the loading and unloading of the ancient ice. The word isostatic refers to the balance between the crust and the mantle it floats upon, and the adjustment is the ongoing movement as that balance is restored after the great disturbance of the Ice Age. It is a process that unfolds not over years or centuries, but over many thousands of years, because the rock of the mantle flows so slowly that the crust is still, even now, thousands of years after the ice melted, settling toward its new equilibrium. The rising of the once buried north and the sinking of the surrounding forebulge are two faces of the same phenomenon. The Earth slowly and inexorably readjusting to the disappearance of a weight it carried for tens of thousands of years. What makes this discovery so remarkable is that it connects the present-day movement of the ground to an event that ended long before human civilization began. The ice sheets melted away thousands of years ago, and yet their influence persists, written into the slow sinking of the land today. It is a striking reminder that the Earth has a long memory, that the great events of its geological past continue to shape its surface in the present, and that the ground we stand on is still responding to forces set in motion in an age of ice we can scarcely imagine. When scientists measure the Midwest sinking today, they are, in a very real sense, measuring the lingering echo of the Ice Age, the crust still relaxing from a burden that was lifted before recorded history. The cause of the sinking is not something happening now, but something that happened long ago and whose consequences are still playing out in slow motion beneath our feet. The precision with which scientists can now measure this movement is what has allowed them to confirm the explanation. Using networks of extremely accurate positioning instruments and satellites, they can track the vertical motion of the land to within tiny fractions of an inch per year, mapping in detail which areas are rising and which are sinking across the continent. When they do this, a clear pattern emerges that matches beautifully what the theory of glacial isostatic adjustment predicts. The regions that lay beneath the thickest ice are rising the fastest, while a ring of land around them, including the Midwest, is subsiding, exactly as the collapse of the forebulge would require. The measurements and the theory align, and it is this correspondence between the precise observations and the deep time explanation that has given scientists confidence that they have truly found the reason for the sinking. The pattern in the data is the fingerprint of the vanished ice. To really grasp how the crust can behave this way, it helps to abandon the intuition that rock is perfectly rigid, because on the timescales and under the pressures involved, it simply is not. We are used to thinking of stone as hard and unyielding, and over the span of a human life, and under ordinary forces, it certainly is. But the Earth's mantle, the vast layer of hot rock beneath the crust, behaves over long spans of time less like a solid and more like an extraordinarily thick, slow-flowing fluid, capable of oozing and shifting under sustained pressure across thousands of years. When the ice sheets pressed down on the crust, the mantle rock beneath was slowly squeezed sideways, flowing away from the load like putty pressed under a thumb, and it was this displaced rock that welled up beneath the surrounding regions and raised the forebulge. When the ice melted, the process reversed, the displaced rock flowing slowly back toward the unburdened center, and the forebulge sagging as its support drained away. It is a strange and wonderful thing to contemplate, solid rock flowing like a fluid, but it is exactly this slow plasticity of the deep earth that makes glacial isostatic adjustment possible, and it unfolds at the pace the mantle allows, which is to say across many thousands of years. The scale of the ancient ice that set all this in motion is difficult to overstate, and appreciating it helps explain why the aftermath persists so long. At the height of the last ice age, the great ice sheet that covered much of North America was in places miles thick, a mountain range of ice spread across an entire subcontinent, holding so much of the world's water frozen upon the land that sea levels around the globe were far lower than they are today. The sheer mass of that ice, bearing down on the crust for tens of thousands of years, depressed the land by hundreds of feet in the most heavily loaded regions. When a burden of that magnitude is applied for so long and then removed, the recovery is not quick. The crust and mantle need an immense span of time to flow back into balance, which is why, thousands of years after the last of the ice disappeared, the adjustment is still underway, the north still rising and the forebulge still falling. We are living, in effect, in the long tail of the Ice Age, in an era still being shaped by the melting of ice that ended before the first cities were built. It is important to be clear about the pace and the scale of this sinking, because the words "the ground is sinking" can sound alarming in a way the reality does not warrant. This is not a dramatic collapse, not a sudden dropping away of the land, not anything that anyone living on it would ever notice in the course of their life. The subsidence proceeds at a rate of a tiny fraction of an inch per year, so slow that it amounts to only a modest lowering over the span of a human lifetime, and even over centuries the change is gentle. It is a geological process, unfolding on a geological timescale, and it poses no immediate threat to the people or the buildings or the farms of the Midwest. No one is going to wake up to find their town noticeably lower than it was. The sinking is real and measurable, but it is exceedingly gradual, the patient movement of the earth over spans of time that dwarf the human experience. That said, even a very slow subsidence can have real consequences when it accumulates over long periods and interacts with the things human beings care about. One area where the slow sinking matters is in the management of water and the mapping of the land, because when the ground shifts, even slightly, it can affect the flow of rivers, the drainage of low-lying areas, and the precise elevations that engineers rely on for everything from flood control to construction. Over long spans, the gradual tilting and sinking of the land can subtly alter how water moves across the landscape, where it pools and where it drains, and these effects, while small, must be accounted for in the careful work of managing a continent's water and infrastructure. The sinking is not a catastrophe, but it is a factor, a slow background movement that engineers and planners have to keep in mind as they build for the long term. It is also worth distinguishing this deep, natural sinking from the other, faster kinds of subsidence that afflict some regions and that stem from human activity. In places where people pump great quantities of groundwater or extract oil and gas from beneath the surface, the ground can sink far more rapidly as the removal of those fluids causes the earth to compact, a process that can drop the land by feet over mere decades, far faster than the gentle geological adjustment of the forebulge. These human-caused subsidences are a different phenomenon, more localized and more rapid, and in some parts of the Midwest and elsewhere, they can add to or overwhelm the slow natural sinking. But the broad, continental-scale subsidence that scientists have now explained, the sinking that affects the whole region rather than isolated spots, is the deep and ancient legacy of the Ice Age, a natural process that would be occurring regardless of anything humans do. Understanding the difference matters because the natural sinking is slow and unstoppable and harmless in the near term, while the human-caused kind can be fast and damaging and, crucially, within our power to slow. There is a further consequence of this deep, slow sinking that connects it to the concerns of coastal and low-lying regions, and it is one scientists increasingly take into account. As the land in a given area settles, even by a tiny amount each year, it changes the relationship between the land and the water around it. In places where the sinking land meets the sea or the Great Lakes, the gradual lowering of the ground can make rising waters seem to rise even faster relative to the shore, compounding the effects of any change in water levels. A coast that is itself sinking experiences the encroachment of water more acutely than one that is stable or rising, because the land is coming down to meet the water, even as the water may be coming up to meet the land. This is why understanding the pattern of glacial isostatic adjustment matters not only as a scientific curiosity, but as a practical input into planning for the future of low-lying areas, where every fraction of an inch of land movement accumulated over decades adds to the challenge of living alongside the water. The slow sinking of the forebulge in these places is not merely an abstraction, but a quiet contributor to the changing balance between land and sea. The discovery of why the Midwest is sinking is ultimately a triumph of scientific detective work, a case in which careful measurement and deep understanding of the Earth's history combine to solve a genuine puzzle. For a long time, the pattern of rising and sinking land across the continent was not fully understood, but by bringing together the physics of how the crust flexes, the history of the ice ages, and the precise data of modern positioning technology, scientists assembled an explanation that fits all the pieces. It is a beautiful example of how understanding the past unlocks the present, of how an event tens of thousands of years ago, the growth and melting of continental ice sheets, turns out to hold the key to a movement of the ground still occurring today. The answer was not to be found by looking only at the present, but by reaching back into the deep history of the planet and following the long, slow consequences forward to the present day. So the next time you hear that the ground under the Midwest is sinking, you can understand it not as a cause for alarm, but as a window into the extraordinary history of the continent. The land is settling because tens of thousands of years ago, great sheets of ice pressed down upon the north and pushed up a bulge around their edges, and now, in the long aftermath of the melting of that ice, the bulge is slowly collapsing back down. The Midwest sits upon that fading swell, sinking a fraction of an inch a year as the crust of the Earth completes an adjustment that began when the Ice Age ended. It is a movement measured in the finest fractions, a legacy of a vanished world of ice, and a reminder that the solid ground beneath us is not fixed and eternal, but part of a living, moving planet that carries the memory of its past in the very shape of its surface. Scientists have found the why, and the why is a story of ice and rock and deep time, of a continent still quietly reshaping itself in response to a weight that was lifted long before any of us were here to feel the ground begin, at last, to sink. It is, in its own way, a humbling and beautiful thought that the firm and familiar land of the heartland is not truly finished, not truly settled, but still moving through the final, patient chapters of a story that began in an age of ice, a story whose ending is